So this video is designed to help you get past that sticky bit at the beginning when you don't really know how a Pico H or a Pico W works. So first of all, I'm going to pop it into a breadboard. This Pico H has the legs on it. They're called pins, and you can buy them either with or without the pins. This is the Pi Hut website. It's a good source of components. And you can see when I search for a Pico, there are various options. Now the W stands for wireless, don't worry about that, we'll do those later. And this is the basic Raspberry Pi Pico. And you can see here it's got no legs on it, no pins, doesn't have any headers. I recommend getting it with the headers because then you don't have to muck around doing loads of soldering, and we can push it straight into a breadboard. So when you are putting it into a breadboard, try and get it the right way round. So you want it so that the 1 is in the bottom right hand corner. It just makes it easier later when we are looking at wiring diagrams. And make it so that the silver micro USB connection is to the right, and just align the pins and then push it in while on a firm surface, and it should just click into place. So we're going to start coding in a minute, so we need to connect our Pico to the PC. It's a micro USB cable connection, not the more modern USB-C. Make sure you get it the right way round. And although I am using a breadboard, you could easily just use it straight out of the box, a really basic Pico without the headers. But what I am suggesting you don't use is the wireless version. That's slightly different code, so we'll talk about that one later. So we're going to use the free Thonny app to write code and send it to our Raspberry Pi Pico. There are other apps you can use, but this one works very well with the Pico, and it works on a variety of platforms. If you need to download it, go to this website. It's pretty quick and easy install, and as I say, no viruses or adware. Now if your Pico device is new, the chances are you are going to need to install the operating system MicroPython, and we do that through the Thonny app. If you can't see a Raspberry Pico option in this drop down in the bottom corner, you do need to install MicroPython. Now we don't need to do this every time we plug in, but because we're installing the operating system MicroPython, we need to hold down this boot cell button. It's a security feature, and you have to hold it down and then plug it into the cable that is connecting the Pico to the computer. So go back to the Thonny app, look in the bottom right hand corner and click on the drop down. Hopefully now you can select Install MicroPython. Click the variant drop down and select the Pico/Pico H option. Once it says done, you can click close. Now you can connect to the Pico by clicking the drop down in the bottom right hand corner and selecting Raspberry Pi Pico. We're now finally ready to write a program to test that connection. A great way to test your connection from the Pico to the PC is to make the onboard green LED light flash. So first we need to import our libraries. Make sure you use a capital P for pin. And we are also going to import the time library. Now we can define our variable, and it doesn't actually matter what you call this, but a descriptive variable would be this. But it is important that we assign the value 25 here, because that is the internal connection that sends signals to the onboard green LED. This command makes the green LED turn on. This makes it pause for a couple of seconds, and then we'll turn the LED off again. Okay, let's run the program to see if the green LED on the Pico actually does flash or not. Okay, now you've got that working. Here's a challenge for you. Can you edit the code to make it flash 3 times? And then, if you have some coding experience already, you could maybe do a for loop or a while loop. So pause the video now, have a go at making it flash, and then when you're ready, when you've had a go, unpause the video and have a look at the solution to see if your ideas match mine. Okay, so this is the code that we have already used that made it flash on for 2 seconds and then off. And this variable here, it doesn't matter what that variable, that could be a different variable name, but you can see that that variable has been assigned a value, and that value 25 means it's connecting, physically connecting it to the onboard built-in green LED. So we can use a descriptive variable, and we're making the green LED flash on with the 1 and then pause for 2 seconds and then flash off. So how do we make it repeat? Well, we could copy and paste. I'm sure you've thought of that. And we could make it repeat 3 times. So on, off, on, off, on, off. But have you spotted the deliberate mistake? Right, so it goes on here, pauses for 2 seconds, and it goes off here, but then immediately it goes on again. And that happens so quickly you would not see the off at all. So it would go on, off, on. Okay, so we need to make sure that we include a time.sleep after each command, otherwise it will change again onto the next command too quickly. So this works. If you run this code, it will flash on and off every 2 seconds, and it will repeat that on-off sequence 3 times. But although that works, that's not very efficient, because we are duplicating these commands several times, and there are better ways to actually make a LED flash. So let's go back to just one lot of on and off, and if we put it in a for loop, it will loop that number of times. So if we do for in range, let's make it loop 5 times. Now, anything that is indented is a part of the loop, so we have to highlight the commands, and then to the left of the Q key on your keyboard is the tab key. So we tab in those 4 commands, okay? That means that those commands are a part of this for loop and will loop 5 times. So if that was accidentally left like that, it would not be a part of that for loop. So now if we run that, it would go on and off, pausing every 2 seconds. But before we test it, let's just make it do it every half a second. Okay, so if we run that now, it should go on and off 5 times. So hopefully that did work for you. If you are having problems, people tend to forget that colon, so watch out for that. Make sure your indentation is correct, so these 4 commands are a part of that for loop, and double check that your assignment, this value, is correct to set a value for this variable here. For example, make sure that is a capital P there. Okay, so what else can we do? Well, you could use a variable, and we could set that as a timer on how quickly we want it to delay. So if we do input how long to pause for, so that is an input statement, and it will add a value to the word delay, and then we can, instead of using hard-coded times here, we can use this variable. Now that means at the moment it won't work because you've got an input statement which automatically uses the data type string. So that would be like doing, if we had a 2-second delay, that, but because it's in speech marks it wouldn't work properly, it would make a mistake. See, it doesn't like it. So what can we do? Well, we just convert it to an integer, a whole number. Okay, so now it's pretty much exactly the same, but we've just wrapped it in int. Okay, so now when we run that, how long to pause for? Well, I want it to pause for 1 second on each flash. So let's see if that worked. So we've made it flash repeatedly by copying and pasting these commands, and we've made it flash using a for loop, which I'm just going to take back to 0.5 seconds. Okay, and so that's looping 5 times. It could be 10 times, it could be 3 times, it doesn't matter. You change that value in here if you wanted to flash a different number of times. But what if you wanted it to flash forever? Well, instead of a for loop, you would just do while true. Now that means it would flash endlessly. And the only time it would actually stop is if you pressed the stop to actually stop the program from running. So hopefully now that's been a good introduction, and one of the reasons that this is quite cool is that we haven't connected anything to the breadboard. There's no opportunity for any wires to be badly connected. The code is quite simple and the connections are quite simple. So I often use this very simple command just to check my connection to the PC is sound before I move on to adding other things like motors or sensors or LED strips, and we're going to talk about that in future videos.